So on our prerequisites, if I'm graphing something like number 9, this is where your parent functions come in play. You really need to be able to sketch something like this quickly because this would then lead to continuity, okay? So I would say to myself, I have got one equation here that is just a horizontal line at -1, and it begins at -1, and heads to the left. This piece right in here got some of you confused. Absolute value of x just means x can be between -1 and +1 because absolute value makes everything positive, right? So this means the same thing as that. Okay? So I have 3x plus 2, which means I know it has a y-intercept here. It has a slope of 3 going up to here with an open dot, and a slope of 3 going down to here with an open dot. But if an open dot lands on a closed dot, what is it? Closed, right? So that is that. There's my line. Then my third line starts at x equals 1, has a y-intercept of 7, and a slope of -2. I don't really need that y-intercept of 7. I more will plug in the 1 real quick to say it starts at 5. So 1, 2, 3, 4, 5. Again, closed dot fills your open dot. Slope of -2 goes that way. So on that one, my domain then would be all real numbers because it goes all the way to the left, all the way to the right. Range, this piece keeps going down, right? So -infinity up to that y value of 5. Okay. And then the other one I heard on this page was 16. Is that correct? Okay. So 16 on this page. All right, so these are more of our rational functions. If we want to find asymptotes, horizontal, vertical, holes, x-intercepts, sketch the graph, we want to factor everything. So in 16, I'm going to lead off with saying that's the same as 2x plus 3, x minus 3, x plus 2, x minus 2. Can't cancel. So if I'm making my list, no holes. I have vertical asymptotes where?
Plus or minus 2.
Plus 2 and -2. I'm going to throw in here x-intercepts. I'm not sure it asked for those, but it can help me graph. X-intercepts are from setting which part equal to 0? Top. So I have those at plus or minus 3. Horizontal asymptotes. Which case are we in? It's DC. Therefore, I'm going to divide my coefficients. I tend to go back here to get that and say that's y equals 2. So then I'm going to draw myself a sketch here. I know I have vertical asymptotes at 2 and -2. I have a horizontal asymptote at 2. I have x-intercepts out at 3 and -3. And that is like the information that I have right now, okay? What do I know how to graph from this? The left and the right. I have no actual idea what's happening in the middle, which means I just have to figure out what's happening. I have 3 x values in the middle there. I have -1, 0, and +1. I can plug those in and see what's going on. 0 being the easiest one. If I plug in 0 for my x's top and bottom, I get -18 over -4, which reduces to 4.5, right? So I know at 0, I have a y-intercept of 4.5. I could then plug in 1 and -1, but if you're looking at that, let's think smarter, not harder. If I plug in two x squareds, either 1 or -1, what are they going to be?
Positive.
They're both going to be positive. They're both going to be the same. So I wouldn't have to plug in both. But if they're both going to be positive, I really just need to know if they're like larger. I would guess they're probably larger because why would it go like down? But I would maybe plug in 1 and just see. So 2 times 1 minus 9 is -8, so that's -16. 1 minus 4 is -3. This gives me like 5 1/3-ish when I'm plugging that in, which is larger than this, and that would match on the other side. So there's that.
But is it like if the graph alive?
Okay, so what I'm looking at in 17 here, it's a quadratic, and I want to know where that quadratic is greater than 0. So when I'm doing that, I'm going to mentally or actually just write it down on my paper and factor. I know that I have x-intercepts at 4 and -3. So that means I have a quadratic that crosses at 1, 2, 3, 4, as well as -3. Oops, that's kind of like not in the right spot. And I know it is a upward facing U because it does not have a negative, yes? So this is asking me the question, where is that quadratic above 0? Well, which parts of this are above 0? That piece and that piece, right? So we write them like a domain or a range. So I say that left section would be from -infinity up till we hit -3. I use a parentheses because it does not say equal to 0, it just says greater than. I then continue and go from 4 out to infinity.
So you don't need to do any of that, like plus or minus?
Nope. Nope, nope, nope. The plus or, do you mean like the end behavior?
Yeah.
That you need on 19 right underneath it. Okay? So in 19, if I'm looking at that, remember this is like the zeros with multiplicity and like the degree. So I count up all my exponents and I say to myself, what degree is this one? 6th degree. Mm-hmm. Yep. So I know one of them is at 2. One of them is at -1. One of them is at 5. I know it is a 6th degree with a positive leading coefficient. So which way do my ends go? Up. Both. So at -1, it's a cubed. So it crosses through. At 2, it's a bounce. At 5, it crosses through. Based off of my polynomials. Therefore, I would like to say which section of this graph is less than or equal to 0. Well, which piece is that? -1 to 5 the whole way with brackets.
Because it's greater than.
Because it is equal to.
Not greater.
Oh my gosh.
I mean.
Okay. This one is where we did even degree or odd degree. Your leading coefficient was positive or negative. Even positive, both ends go up. Even negative, both ends go down. Odd is down, up, or up, down. Okay. In 18, I am going to say I have a vertical asymptote at -4. I have a horizontal asymptote where? Y equals 3. I would probably throw in there finding my x-intercept because right now I have no points. So that is like 2/3.
Yes, it's 2.
Okay, so I've got 2/3 there. So that is this. If I felt like I needed more information, I would have solved for the y-intercept. The y-intercept by plugging in 0 top and bottom is -1/2, which is about here. So that tells me I have a branch here, and I would assume I have another one over here. I'd like to know which section of that graph is less than or equal to 0, and that's a y value, right? So that's this section, right? So where does that section start on the left? -4 with the parentheses, because it gets real close to -4, that asymptote on the left, and comes along till it hits the y or x-intercept, excuse me, at what? 2/3. And that is equal to, so that piece, excuse me, I would use a bracket. I can't use a bracket on the -4 because it does not touch -4. That's the asymptote.
And so.
But I
since it's
can
like
use
up,
it
you wanna
at
get
2/3.
Closer to.
Okay, so if I'm looking at the ln one here, this is an ln function that is moved which way? Right to. Normally the ln one, all I know about it is that it goes through 0 or 1, 0. So usually I know that. But if it's moved right 2, it's going to go here, right? I want to know on this one, where is this graph greater than 1? So my next question is, do I know where this hits 1? I don't necessarily, but could I solve for it? So look back at this equation here. If I want to solve for x where it's equal to 1, let's just pretend that's an equal to sign. How do you get x by itself? How do you get rid of ln? You can switch it into exponential form, or you can think about like using base, what's the base? E. So if it is base e, you're going to switch it into exponential form. E to the first is equal to x minus 2. Then how do I solve for x? Add 2. So what you found here without a calculator is that right here has an x value of e to the first plus 2, comma 1, not 2, sorry.
Wait, Miss Sonny,
Yep.
on that, my graph of it,
Mm-hmm.
wouldn't it be down 1 because like you move it?
I did not move the 1 on it. I left the 1 there, I just graphed the left side.
So we did ln minus 2.
We're going to be greater than that value of 1 in this section, right?
So e to the first plus 2, comma, infinity.
Yes. E to the first plus 2, comma, infinity.
And okay, what if there was a greater than or equal sign? Like, could you put
That would
greater
be
than-
like with a bracket.
And you would put greater than on the e because
Mhm.
that is technically like a
Yep,
value.
because that's where it would touch. Yep. 23 and 24 are weird factoring, okay? Even 22 is a little bit different, but did we all recognize in 22 you could pull out an x plus 2 squared?
Yeah.
That's what was the intention. So when you look at something like that, remember that if there's anything you can pull out, even like a parentheses factor, you can do it. So I've recognized that both of those terms have an x plus 2 squared. I'm going to pull that out and see what's left here. If I pull an x plus 2 squared out of an x plus 2 cubed, what am I left with? I'm just left with x plus 2. What's left from that second term? Plus 4, which I can combine my 2 and 4 and just get a nice little factor there. Okay, so that cleans it up real nicely and is like that. So really, what's the goal of that? Well, let's say that's like an inequality, the polynomial one. In the form it was, I would not know how to graph that. Like if I wanted to say where is that greater than or equal to 0? I don't know how to graph that, what I was given in 22. Can I graph this? That would be like a third degree polynomial. It'd be a double root at -2, a root at -6. I could graph that, okay? Next unit, when we get into derivatives, we're going to see some weird places that we have to factor some stuff out to clean it up nicely. And so that's really where this kind of stuff comes into play. So that being said, let's look at 23 here, okay? So in 23, we kind of have to back up to an easier question to look at 23 the right way. If I had given you x cubed y plus x squared, what would you tell me you could pull out?
X squared.
An x squared. Why do we pull out the x squared?
Because they're both
How do I know not to pull the x cubed?
because you don't have an x.
You use the smaller one, right? So now use that same idea when it comes to negative exponents. Negative numbers are smaller than positive numbers, yes? So look through that. Which is the smallest a, actually?
To the -4.
-4. It's more negative, right? So that is the smallest a value. What about your b? B, just single b. Okay, so we're going to take as a greatest common factor a to the -4th and a single b. Let's see what we have left. The first one's easy because I've pulled that a to the -4th. It's gone. What am I left with for b's? B squared. Now, when you pull a negative exponent out of a positive exponent, you don't think about it this way, but when you factor out an x squared here, you're dividing it, right? So when I ask you to pull an x squared out of that original example, how do you know how many x's are left in the first one? Well, you're just thinking, dividing an x squared into an x cubed, how many's left? 1. right? So think in terms of division. If I am pulling an a to the negative fourth out of that, what's our division rule for exponents? You subtract them. So I'm going to get a to the what power? 7th. Because minus a negative turns into a plus. So I get a to the 7th. What happens to the b?
It's just one.
It's gone, right? So now I'm going to think the same way here, like I'm dividing. If I take negative 2 minus a negative 4, what am I going to get? A squared. And I took one of the b's out, so I'm left with b. The only thing I have left to do then is this first part. Anything that has a negative exponent goes on the bottom of the fraction. So I would take a moment here and put this a to the 4th on the bottom underneath here. Okay. 24. If I'm pulling the smallest exponent, that's pulling x plus 2 to the negative 1/2, right? So think in terms of division. If I pull that x plus 2 to the negative 1/2 out front, I'm going to use brackets here just because I've already used parentheses. If I'm pulling that out of this,
You're just left with an x plus 2.
I'm just left with an x plus 2 because my 1/2 minus negative 1/2 gives me 1. X plus 2. On the second one, I've pulled the x plus 2 to the negative 1/2. What am I left with?
4.
Just the 4. So that factor in the brackets becomes what? X plus 6, which goes on top of the other
So
one.
you would say root of
Root.
x plus 2.
Root of x plus 2.
Because it's 1/2.
Yes. So that one, you can truly see that that's actually a smaller, shorter version. And that's why we would do it, because it's cleaned up a whole lot nicer. So pulling that negative exponent, it's a different skill we haven't looked at yet, but factoring works the same way, okay? All right, so when we are looking at the sine of 2x ones, these are the ones last year that we said, okay, what if we just called this like a nice big theta? Would I know where my sine value is equal to negative 1? I do. And using my unit circle and chart, where does my sine value equal negative 1? 3 pi over 2. But we said these are our answers not for x, but for 2x, which means I'm going to have to divide everything by 2. However, when we talked about these in class, when we divided by 2, it reduces our answers, giving me more answers than I would have had in the original rotation. So the rule of thumb I said is if it's a 2x, we go 1 rotation for the first set of answers, 2nd rotation for the 2nd set of answers, and then divide. So if I go another full rotation around from 3 pi over 2, what's a full rotation?
Oh, 2 pi.
It's 2 pi, it's a full 2 pi
Oh, 4
in terms of halves.
pi over
Okay, so that's adding 4 pi over 2 and gives me 7 pi over 2. Then I divide.
Oh, you want to do that and then divide?
Yes, you want to add first, because if you did it after you divided, you're not necessarily going to get an answer that gives you sine is negative 1. That doesn't work that way.
Are we gonna have problems where, I remember like on one of the tests it was like a sine of 2 or 3x, like stuff like that.
The
So I don't
double
remember how to
angle
do
stuff.
that.
Or you have to like do this plus that, right?
So if it was like a 3x,
Yeah.
we had to do like first rotation, second rotation, third rotation, then divide by 3.
Okay.
Oh, so that was just a
This-
rotation.
Yep.
Or
This, for some reason, according to when I talked to her, is one of the most common solvings.
There was one though.
The
that
other
was
ones are not as common.
sine